Hey there, fellow tech enthusiasts. We're about to dive into a world where old-school cool meets cutting-edge AI. Imagine teaching a computer to see using toys from the past. That's right, we're talking about the Fisher-Price PXL2000 camera and the iconic Lite-Brite. It sounds crazy, but it's a project bursting with potential. Think about it. AI like ChatGPT is amazing at understanding and generating text, but it experiences the world primarily through words. What if we could give it the power of sight? It's like teaching a kid about colors using a box of crayons. It makes learning fun and tangible. This experiment isn't just about nostalgia, it's about exploring new frontiers in AI. It's about proving that innovation can come from the most unexpected places. Get ready to have your minds blown as we unlock the visual potential of AI with a little help from some retro tech magic. Let's start with the star of our show, the Fisher-Price PXL2000. This vintage gem isn't just a toy, it's a piece of tech history. Back in the 80s, it let kids make their own pixelated movies, and guess what? It still works like a charm. The PXL2000 is like the eye of our AI system. It captures light and movement, just like a regular camera. But here's the twist. It records everything in that classic pixelated style. Remember those old school video games with blocky graphics? That's the aesthetic we're going for. It might not be high definition, but it's perfect for our experiment. Why use this retro camera? Well, it's simple, affordable, and it gives us the perfect low-resolution visual data that's easier for AI to process. We're not looking for photorealism here. We want to give ChatGPT a basic understanding of light and shadow, movement and stillness. Now here's where the real magic happens. We need to translate the PXL2000's video output into something ChatGPT can understand: digital data. Think of it like translating a language. The camera speaks in analog signals and ChatGPT understands digital code. We'll use a device called a microcontroller to act as our translator. It takes the analog video signal from the camera and converts it into a stream of ones and zeros. These ones and zeros represent the brightness and position of each pixel in the image. It's like converting a beautiful painting into a paint-by-numbers scheme. This digital translation is crucial because it turns visual information into a language that AI can comprehend. It's like giving ChatGPT a set of building blocks that it can then use to learn and make sense of the world around it. Okay, we've got ChatGPT speaking the language of pixels. Now, how do we actually let it see what those pixels represent? Enter the Lite-Brite. Remember those boards with the little colored pegs that lit up? That's our visual output device, our AI's very own light show. We'll connect the microcontroller to a grid of LEDs that mimics the Lite-Brite's pegboard. As the PXL2000 captures images, the microcontroller will light up the LEDs in a pattern that corresponds to the pixel data. It's like taking those ones and zeros and turning them into a dazzling display of illuminated dots. Imagine this. The PXL2000 sees a spinning top. The microcontroller translates that into pixel data, and the Lite-Brite bursts into a mesmerizing dance of lights, showing the circular motion and changing colors. It's a visual representation of data, a way for us and the AI to see what the camera captures.